Problem 22. Let S be the set of circles in the coordinate plane that are tangent to each of the three circles with the equations x squared plus y squared is 4 and x squared plus y squared is 64 and x minus 5 plus y squared is 3. What is the sum of the areas of all circles in S? Okay, so I have to draw a diagram, and I will try my best to draw these circles. So the first one, it's going to be like this, right? This one right here, x squared plus y squared is 4, where the radius is 2. The next one, this is not going to be drawn to scale, but you guys get the idea that obviously this radius is 8, so it's much bigger. So it's like this. So that one is this x squared plus y squared is 64. And then you got this one, where it's not at the center anymore. The center is now 5, 0, so somewhere here. And its radius is root 3. So it's going to be something like this. Yeah, it's going to be a smaller circle. Well, I don't know if that looks smaller, but you guys get the idea. I mean, I'm just trying to illustrate it with a diagram. It doesn't have to be super accurate. Okay, so those are the three circles. Now, what are they asking here? What are they asking? The set of circles in the coordinate plane that are tangent to each of the three circles. Okay, so that means there's a bunch of circles that are tangent to each of the three circles. So I'm just going to draw one. Because if I draw a whole bunch of circles, the entire diagram gets very, very confusing. So let me see if I can draw one. One such circle. I don't even know it's going to look like a circle. Well, that's actually not bad. That is one such circle. It is tangent to the other three. It's tangent to this one right here. It's tangent to that one right there. And it's tangent to this one. Okay, that's just an example. So what I have to do is figure out how many such circles are there. And then what is the area of each of those circles? Okay, well, here is one. Now, how would I figure out the area of that circle? I drew it, but okay, well, how do I get the area? To get the area, I would need the radius, right? So how do I figure out the radius? Well, I'm going to draw a line that hopefully, and as I had previously mentioned, I think I'm a little bit off. This is the tangent point, but you guys get the idea. Okay, so now that line represents the diameter of that red circle, right? But we do know a few things, that the radius of the small circle is 2, because it's x squared plus y squared is 4. And that is basically, that 4 is representing r squared. So that's 2 also. And then this point, I'll just call x. So that means the diameter of that red circle are x plus 4. Correct? Okay. Now, we also know that the radius of this guy, the x squared plus y squared plus 64, since that represents r squared, that r is 8. So that means from the origin to the edge of that circle is 8. So that means that x plus 2 is actually 8. So that means x is 6. So therefore we can substitute that 6 there, and therefore the diameter of that red circle is 10, and the radius of that red circle is 5. So therefore the area of that red circle would be 5 pi squared, which is 25 pi. You got it? So that is how you would figure this out. Now, I think so far you guys understand it. So I'm not going to draw a whole bunch of circles and go through every single one, although I am tempted to do that. And I might even do that because I'm curious as to whether you can do it yourself. But I'll just do it. I don't know. I mean, I'm hesitating not to because I want you guys to figure it out. But let's see how much I can actually provide and how much you guys can do. So first of all, we have to break this into a few categories, right? How is a circle going to look? All the circles will be tangent to the big one. And the big one, instead of calling it big one, I'll call it O. And then this one in the middle I'll call P, and then this one in the side I'll call Q. Now all the circles that we draw, like I drew this red circle, will be internally tangent to O. So all circles in that S are internally tangent to O. Okay, so that is well established. Now we have to figure out the other two. So we have 4 categories. We have the first category where you have P is internally tangent to S, and Q is externally tangent to S. And that is exactly what I drew up here. That red circle that I drew up here, that is an example of this scenario. And we figured out that the radius there was 5. But here's the thing. There are 2 such circles. So let me meet you halfway. I drew one, you drew out the other one. So you draw the other one. I think that's a pretty good compromise. Okay. All right. So I think that we've agreed there. Okay, so now we got scenario number 2, scenario number 3, and scenario number 4. The next scenario is P is externally tangent to S, and Q is also externally tangent to S. So what is an example of that? Let's see if I can do that very quickly without making this diagram too messy. So we got the big one, we got the small one, and then we got the small one over here. So let's draw a circle that meets this criteria. Both are externally tangent, and it would be something like this. So a tangent point here, tangent point here, tangent point there. And that one, same thing. How do I figure out the radii? It's the same kind of story. You draw a line that connects the tangent points, and then you would notice that if the red circle has, let's say, a diameter of x, this is 2. So the diameter 2 plus x is equivalent to the radii of the large circle, which was 8. So therefore x is equal to 6, and x represents the diameter of that red circle, so the radius would be 3. So here we have r equals 3. And similarly, there's 2 such circles, and you draw the other one. I think that's a pretty fair deal that we have going here. Okay, next one, over P is externally tangent, and Q this time is internally tangent, internally. So let's draw this one. Hold on, let me draw this one here. So same kind of story, we got to draw the big one, the little one, and the little one on the side. And then we got to draw a circle that is matching this criteria. So I think something like this. Oh boy. Let's see here. Something like this, I think. Yeah. So it's going to be tangent here, here, and here. And therefore, same kind of story. We want to find the radii. And this is terribly drawn, but you guys understand. Same thing. This is 2. The diameter is going to be x, so the same story. 2 plus x is the same as 8. X is 6, so therefore the radius of that red circle is 3. So this is r equals 3. And then the last one is P is internally tangent to S, and Q is also internally tangent. So that one, let's see if I draw a little bit bigger. I think it helps if it's a little bit bigger. So we got a bigger one this time. So we got the one that's got a radius of 8, the one that has a radius of 2, then we have a radius here of root 3. And then I want, let's see here. I'm going to draw the line first because it seems like the line doesn't seem to match when I draw it. And how am I going to draw this line? I'm going to draw the line like this, like that. And then I can probably match up the circle. So we want, let's see here, something like this. Yeah, something like that. That will work. I mean, that's not perfectly drawn, but it's okay. This is 2, this is 2, this is x. So we know that 4 plus x is the diameter, but we also know that 2 plus x is equivalent to 8, so x is 6. So 4 plus 6 is the diameter. That means the diameter is 10. So therefore the radius of that guy is 5. So this is radius is 5. And again, these have 2, and there's 2 circles like that as well. So we want the area. Okay, let's figure out the areas. Here, the radius is 5, so the area would be 5 squared times pi r squared. But remember, there's 2 such circles, so we have to multiply by 2. Here, the area is pi times 3 squared, 2 such circles, you have to multiply by 2. Here, we have 2 such circles with the radii of 3. So again, 3 squared, multiply by 2. And the last one, pi, the radius was 5, so 5 squared, multiply by 2. So this is what, 50 pi? This is 18 pi. This is 18 pi, and this is 50 pi. So I think that's 136. Yeah, if you add them all up, they want the total. It's 136 pi. So that is the answer, and that would mean E. Problem number 23. An ant, Amelia, starts on the number line at 0 and crawls in the following manner for n1, 2, 3, and Amelia chooses a time duration tn and an increment xn independently and uniformly at random from the interval 0, 1. During the nth step of the process, Amelia moves xn units in the positive direction, using up tn minutes. If the total elapsed time has exceeded 1 minute during the nth step, she stops at the end of that step. Otherwise, she continues with the next step. Taking at most 3 steps in all, what is the probability that Amelia's position when she stops will be greater than 1? All right. So we're going to make a little table here. We have step, we have time, and we have distance or increment. So we only have 3 steps, right? We have 1, 2, and 3. For time, it's represented by Tn. So we have T1, T2, and T3. And then for distance, which is represented by xn, it would be x1, x2, and x3, sorry. So for each of these, we have just between 0 and 1 as the choices. So that's it. The max time in one step is 1 minute. So the max time, max time in one step is 1 minute. That's it. Because I think this is in minutes, right? Let's see here. There's a time. Actually, do they say in minutes? Yeah, they do. They do. Okay, I was wondering what is the unit. Okay, so that's pretty good. And then she exceeds 1 minute, right? Because they're saying that she stops when her when will be greater than 1. Okay, what is the probability of Amelia's position when she stops will be greater than 1? Okay, I got it. So when she exceeds this 1 minute, that's when she stops. So since the maximum she can go is 1, she would have to take at least 2 steps. At least 2 steps would have to be taken. Yeah. So I think we have to figure out just 2 scenarios. The first scenario is 2 steps, and the second scenario is 3 steps. Because the 1 step scenario will not qualify because we have to exceed 1 minute, and in 1 step the maximum she can go is 1 minute. Okay, so let's do the 2 step one, and then we'll do the 3 step one. Okay, so 2 steps, basically we have step, time, and distance. And this is step 1, step 2, T1, T2, X1, and X2. We basically want T1 plus T2 to be greater than 1. Okay, I got it. And we also, I believe, want X1 and X2 to be greater than 1. Or actually, I think just the time is sufficient. What is the probability that Amelia's position when she stops will be greater than 1? Okay, and then that follows if the total elapsed time has exceeded 1 minute. Okay, I think I got it. All right. So what this basically is a little diagram here where this is T1 and this is T2. And the maximum we can go is 1 for each. So if we make a little diagram here, anything in this range would satisfy that guy. Yeah, I think so. Yeah. So that pretty much means that this area would represent the probability. So that's basically 1/2 base times height. And that's a half. Yeah. But in addition to time, right, we also need the position to be greater than 1. See, they have position, because it's not just the time. The time has exceeded 1 minute, so has the position. So because the position has exceeded 1 minute, we need the same kind of story for the position. So if this is x1 and this is x2, and this is 1 and this is 1, and then you draw a diagram like that, that same kind of story, we want x1 plus x2 to be greater than 1, and that will be represented by the area of that triangle, which would be 1/2 base times height. So that's also a half. So we want this and that. So if you want that and that, you have to multiply those two probabilities, and when you do, you get a quarter. Okay, so a quarter is part of the answer, and that is actually when you have 2 steps. Now we also have to do 3 steps. So 3 steps is the next one, and then eventually we'll combine it with this 1/4. Okay, so 3 steps. Okay, let's think about this one now. 3 steps. So with 3 steps, that would mean that on the 3rd step, you get more than 1 for the time. So T1 plus T2 plus T3 is greater than 1. But that would mean that after 2 steps, you still have not exceeded 1. Because on the 3rd step, you exceed 1 in terms of time. So this actually is going to be calculated with that triangle. It's basically this part right here. And that area would just be 1/2 base times height, which is a half. Yeah. And then, of course, we have to do the distance, which would be that x1 plus x2 plus x3 is greater than 1. But this is a little bit more complicated because now we have no longer a flat plane like this. We've actually got a 3D plane. So we're going to have a 3D diagram here. So this is, for example, going to be x1, this is going to be x2, and this is going to be x3. And then we've got a unit square, right? So let's see if we can draw this like that, I think. Yeah, something like that. Okay. And then we want this scenario. Now, how do we get that on this cube here? We will obviously going to use a volume formula. And I think it's going to be a tetrahedron. So, for example, if I were to, let me do this in a different color. Cut that and cut that. Right, that. And then basically, hopefully you can see that if you make a slice, you'll be able to slice out the part that you don't want, and that would leave the area that you want that represents this right here, this part right here. So we want the bigger part that includes, for example, 1, 1, 1, which would be 1, 1, 1. We want this part, so the larger part of that cube, so that we don't want this part. So this part here, the 3D component of it, is what we have to cut out. So the volume what we want that represents this is the area of the full cube, which is just a 1 cubed, minus the area of that tetrahedron. And that's going to be, the area of a tetrahedron is 1/3 times the area of the base times the height. So this is going to be, let's see here, 1 minus 1 minus 1/3 area of the base. So the base is just this triangle that I just did. So that's 1/2 base times height, which is 1 times 1. And then the height of that would be from here to here. So that's 1. So that's going to be 1 minus 1/6, which is 5/6. Yeah. And so therefore we want this and this. So it would be 1/2 times 5/6, which is 5/12. There you go. So now we have to combine this guy with this guy to get our final answer. So it would be 1/4 plus 5/12. And I believe that would be 8/12. Or sorry, 3. So multiply both sides by 3. Yeah. So, jeez. So we got 8/12. And therefore, that looks to me, if you divide top and bottom by 4, it's going to be 2/3. Okay, 2/3. Yeah, tough question, and that's going to be C. Problem number 25. Let x0, x1, x2, dot, dot, dot be the sequence of numbers where xk is either 0 or 1. For each positive integer n, define s and n to be the sum from k equals 0 to n minus 1 of xk2 to the k. Suppose s times Sn is equal to 1 mod 2 to the power of n for all n greater than or equal to 1. What is the value of the sum? All right, so we have a sum, and we need to figure out this whole thing right here. So what I'm going to do is figure out first what is the sum for S23 and S19, and then I'll subtract them because we got coefficients from S19 to S22 here, 2022. So S223 and S219, like that. So the first one, just using this base formula right here, is the sum from k equals 0 to, in this case, n minus 1, so that's going to be 2022, of x to the power of k and 2 to the power of k. So that's basically x0, 20, x1, 21, plus x 2 to the power of 2, and so on, dot, 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 all the way till x 2022, and then 2 to the power of 2022. Okay, and then similarly, this one is from k equals 0 to 2018, because it's n minus 1 of xk 2k, and that's going to be in the same way, x0, 20, plus x1, 21, plus x2, 2 to the power of 2, plus dot, 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 all the way to x2018, and 2 to the power of 2018. Okay, so now what we need to do is we need to subtract these guys. So if you subtract them, you get S223 minus S2019. And when you subtract them, the only thing you'll have left is, let's see here, the X2019. And that coefficient, let's see, is 2 to the power of 2019, I believe. And then we have x 2020, 2 to the power of 2020. And then we'll have x 2021, 2 to the power of 2021. And then x 2022, 2 to the power of 2022. Okay, we can factor out some big number here, x to the power of 2000. Let's factor out a 2 power, 2 to the power of 2019. And when you do that, you will get just x2019. Then we left with just 2x 2020 plus 4x 2021, and then 2 to the power of 3, which is 8 2022. And this right here, what I have in the brackets, if I'm not mistaken, is identical to that. Yeah, this guy in the brackets. So I think that this is pretty much all I would need to do. Okay, great. So if I divide through by 2009, 2 to the power of 2019, I get 2023 minus S2019 all over 2 to the power of 2019. And we got this, basically this expression that we have to figure out the value of. I think we need to figure out a numerical value. Ah, okay, so the here are the answer choices. So it's a number between 6 and 15. Okay, so hopefully we are moving in the right direction here. 2022. Okay, so now we got to concentrate on this guy here, because this one will basically give us the answer. Okay, all right. Okay, where do I go from here? At this point, I think we need to utilize something that they gave us in the question, which is this guy right here. This 7 times s to the n is 1 mod 2 to the n. So this one, of course, we will need to save for the future, but this 7s to the n is equivalent to 1 mod 2 to the n. All right, so let's give some examples. For example, if you have n equals 2, this would be 7s2 is equivalent to 1 mod 2 to the power of 2, like that, which basically is, let's see here, yeah, that's a correct interpretation. So for example, if S2 was equal to 3, this would mean that 7 times 3 is 1 mod 4. Is that correct? 7 times 3 is 21. 21 divided by 4 is 5 with a remainder of 1. And that's correct, because this represents the remainder when divided by 4. Okay. All right, so I'm just trying to understand this. So that would mean that 21 is equal to 4 times something, well, I'll just call it y, plus 1. And in this case, our y was 5, right? Yeah, so that means that the y has got to be between 6 and 0. Because if it's 7, then it would be divisible by 4 and it would have no remainder. Yeah, because this mod 4 it has to give a remainder of 1. That's what this means for this particular example. So I'm just trying to get parameters here. Okay, so now let's go back to our S2023, and that's got to be the same as 1 mod 2 to the power of 2023. Okay, not as simple. But this basically is the equivalent of saying that S2023 is this 2 to the power of 2023 times some y plus 1. Just like how I did over here. What that y is, I don't know. But it's obviously got to be multiplied by something. And when you do, and add 1, you will get that. So, and then of course we have the parameters that y has got to be between 6 and 0 for this to work. So if I clean this up a little bit, that S2023 would basically be the same as 2 to the power of 2023 times y plus 1 all over 7. Yes, I believe so. Okay, so let's save this guy. And I think we'll do the same thing for the 2019. That's going to be 1 mod 2 to the power of 2019. And then therefore that means that 7s times 2019 is the same as 2 to the power of 2019 times something. I'll just call it x. I don't know what it is. Plus 1. Yeah. And that is when x is between 6 and 0. And therefore S2019 is this 2 to the power of 2019 times x plus 1 all over 7. And this is my other one. So to get this guy, I think everything I need. So let's see here. S2023 minus S2019 over 2 to the power of 2019. Okay, so let's combine them. So we have S2023 minus S2019 all over 2 to the power of 2019. Okay, so let's see what happens here when I substitute these guys. This is 2 to the power of 2023 times y plus 1. And then minus, we got the, oh, I got to put it over 7, sorry. And then this one is 2 to the power of 2019 plus 1. Is that it? Yeah, and then it's all over 7. Yeah, and well, it's all over this guy, 202019, like that. Okay, so let's see here. What can I do here? I can factor out a 2019, and that would leave me with 2 to the power of 4 times y. These ones cancel, this guy and this guy, and minus 1. Or minus x. Wait, did I miss an x in there? Yeah, I missed an x in there. Sorry about that. There should be an x there. Yeah. And then all over 7. And then that's all over 20219, like that. Okay, so I think these 20219s cancel. Yeah. So that leaves me with just 16y minus x over 7. Yeah. And that is the big long song and dance. That is what this is. S2023 minus S2019 all over 2 to the power of 2019. And this guy is equivalent to this, which is basically what they wanted. Way up at the top, that's what that is. What is the value of that? So let's put that in there just in case we're wondering what are we doing. That is the same as that x to the 2019 plus 2x 2020 plus 4x 2021 plus this 8x 2022, and that's equal to 16y minus x over 7. Now you say, okay, well that's the answer, but they want it in terms of a number, because if remember the answer choices are anywhere between 6 and 15. So how do we get a number? Well, I think that's where the parameters came in. If you remember, y is between 6 and 0, and x is between 6 and 0. So let's see here, 16y minus x over 7. If I have to try values of x and y in those parameters. Yeah. Okay. All right, so let's try. Well, I'm not going to try them all. I'm just going to try the ones that work. Give me integer solutions, because I believe it's an integer that is the final value, right? Yeah, it's between 6 and 15. 6, 7, 12, 14, 15. So 6, 7, 12, 14, 15. Can I get any of these? If I can get any of these, I'm in luck. All right, so let's try x equals 1. And let's see, to get it divisible, y could be 4, because that would be 64 minus 1, which is 63. Yeah, 63 would be divisible. That would give me 9. And 9 is not one of the answer choices. Okay, well, at least I got an integer. Let's try again. Let's try x equals, let's go the other way, 6 this time. And I would need to put a 3, because that would be 48 minus 6, which is 42. 42 divided by 7 is 6. And there you go. That is one of the answers. So after trial and error and a whole bunch of calculations, we get 6 as the answer. That would mean number 25 is A.
The figure below depicts a regular 7-gon inscribed in a unit circle. What is the sum of the fourth powers of the lengths of all 21 of its edges and diagonals? For this question, we will use a ruler. Rulers are allowed on these exams. And in a very interesting way, the ruler helps you solve the question. So the first thing I have to point out that this is a unit circle. Now this diagram obviously will not have a radius of 1 because it's drawn a little bit bigger. So we have to scale it down. Now, when you take a measurement with your ruler, you'll find that this has a approximate radius of about 2.9. So we're going to have to scale everything down by a factor of 2.9 because the actual circle is a unit circle. Okay, so here we go. Now, these edges and diagonals, first let's list them. The ones that are sort of adjacent, meaning like, for example, between points 1 and 2, like this is point 1, this is point 2, 3, 4, like that, right? Let's just label them all the way to 7. The ones that are between 1 and 2, those guys, there are 7 of them. Okay? And I'll call that equal to A. And we'll measure them in a few minutes. The ones that are between like 1 and 3, so something like this guy, there are 7 of those. And the distance we'll call as B. And the ones that are between 1 and 4, so something like that, there are 7 of those, and we'll call those equal to C. So essentially what the question is asking us is to find 7a to the power of 4 plus 7b to the power of 4 plus 7c to the power of 4. That's basically what this means. What is the sum of the fourth powers of all the lengths? Okay, so take out your ruler, measure A. When you do, you get 2.5. But remember, we have to scale it down by this 2.9 because it's a unit circle. When you measure B, you get a little bit bigger. It's 4.9, and you scale it down. And then when you measure C, it's about 5.6, and we scale it down. And then you just substitute those values into here. So 7, 2.5 over 2.9 to the power of 4, plus 7, 4.5 over 2.9 to the power of 4, plus 7, 5.6 over 2.9 to the power of 4. And then when you crunch out these numbers, you will get approximately 7 plus 38.5 plus 105, and that totals 147. And that would be C. So there you go. You got a question number 24 solved very quickly with just your ruler. 4 regular hexagons surround a square with side length 1, each one sharing an edge with the square, as shown in the figure below. The area of the resulting 12-sided outer non-convex polygon can be written as m times the square root of n plus p, where m, n, and p are integers, and n is not divisible by the square of any prime. What is m plus n plus p? All right, so here we go. This is that diagram. And this is what we're going to work with. And we are going to split this up into a few sections here. So what I'm going to do first is just draw a line sort of across and down. And as you can see, it's symmetrical. And because it's symmetrical, we can just concentrate on one of these 4 quadrants. And then in the end, we'll multiply by 4 or adjust by a factor of 4. So here is basically our story. The first thing we're going to do is we're going to calculate the area of the entire square. So that's the first thing. And then, of course, we have to subtract from that entire square these 4 corners. And I'll just call that A. So those 4 corners. And then, of course, we have to subtract from it also these purple shaded areas, which I will call B. Right? So in the end, basically, the total area of what we need to figure out will be the area of the square minus 4a minus 4b, right? Because there's 4 of those a's, 4 of those b's, and basically that would be how the area would be calculated. So that's the steps, and in the end, we'll do that whole m plus n plus p thing, so that shouldn't be a problem. Okay. So I'll try to do it step by step so you don't get confused. Okay, so the first thing is that we need to figure out the dimensions of the square. So we are told that the side is 1, so from here to here is 1, so that helps. So on the diagram, I'm going to draw actually a triangle. I'm going to draw it right here. So this triangle right here, right there, like that. And that triangle, I will put it over here to avoid making the diagram messy. So that's the triangle. Now this is a right angle, and since this is a right angle right here, and we know the internal angles of a what is this? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 8. But the hexagon is really what we need to concentrate on. And that hexagon, even if you don't remember the internal angles, you can just figure it out. Hexagon is basically 3 triangles, right? And we know that each triangle has an internal angle of sum of 180. So we have 4 times 180, since there's 4. And then there's 1, 2, 3, 4, 5, 6 internal angles. And that's how you would basically figure out that it's 120. So since that's 90, this in here will be 30. So there you go. And then this is, of course, going to be 60. So it's one of those famous 30, 60, 90 triangles. And as you know, the ratio is the ratio of the sides are 2, 1, and root 3. Those are the ratio of the sides. Now the good news is we know that this side here, right there, is equal to, I believe they gave it to us, 1. So we know that. That's actually given in the question. So therefore, we can easily calculate the lengths of the other sides of that triangle. So this will basically would be a half, and this side would be root 3 over 2. So that means from here to here is root 3 over 2. And by the same logic, from here to here is also root 3 over 2. It would be the same sort of triangle and the same sort of story. So that means that all the way from here to here is going to be root 3 over 2 plus root 3 over 2. So that whole thing right there is root 3. Now we can do the exact same thing on the bottom. So for example, you could do the exact same story from here down to here using this as your triangles. And that would also be root 3. So that means that the full top to bottom length would basically be root 3 plus root 3, but then we've overcounted by the size of the square's length. So we have to subtract that. So I hope that makes sense. So this represents the side of the square. Side of big square. Yeah. So therefore the area of the big square would just be 2 root 3. So this is 2 root 3 minus 1, right? So the area of the big square would be 2 root 3 minus 1 all squared. Got it? Okay, so we've done that. Now we turn our attention to the A, this guy right here. Well, that is actually not that bad, to be honest, because the full length from here to here, we just figured out was 2 root 3 minus 1. So this part would just be 2 root 3 minus 1. And we would have to subtract this 1 again, and then divide by 2 to get from here to here. And this looks to me like root 3 minus 1. Yeah, so that's root 3 minus 1, that dimension. So therefore, since that's a isosceles triangle, I believe, the area will be just be 1/2 base times height, where the base is root 3 minus 1, and the height is also root 3 minus 1, so it'd be 1/2 root 3 minus 1 squared. And then there's 4 of those guys, so I guess in the end we'll have to just multiply by 4, which is not a problem. Okay, so now we turn our attention to the final guy, which is B. And B is the most challenging because it's not as, I guess it's not as intuitive. It's a little bit more complicated. So I'll try my best to explain it. But first I'm going to draw it over here to avoid messing up that diagram. So B kind of looks something like this. This is B, right? And based on the symmetry of the diagram, it's also an isosceles triangle. All right, so we're going to need some dimensions here. We have to figure out what is the lengths of this triangle. So if you look at A kind of helps us, right? This is our A. This is a triangle, so I can use Pythagoras to kind of figure out this length right here, from there to there. So that would be root 3 minus 1 squared plus root 3 minus 1 squared is equal to, and I'll just call that whatever, y, let's say, y squared. Okay? So when you crunch out these numbers, I'll let you do this math. It'll be 2 times 2 minus root 3 under the square root sign. So not a very nice number, but that's what you get. Okay, so that means that this side, or this side, whatever, is 2 times 2 minus root 3 under the square root sign. Now, this is where it gets a little bit tricky. This is a lesser known formula for the area of a triangle. You guys are used to a lot of formulas using sine, I think, but there's a tan formula that very few people know. And that is that the area of a triangle is calculated as 1/4 times the base length, all squared, times the tan of the base angle. Base angle. Let me see if I can move this over here. Yeah. So the base length we have, the base angle is going to be this angle here. And that angle we need to figure out. And how do we do that? Well, that shouldn't be a problem since this is 90 and that's an isosceles triangle. This will be 45. And since this, I believe, was 120, you just have to take 180 and then subtract the 45 and subtract the 120. And when you do, you get 15. So that angle is 15. So there you go. We have pretty much everything we need. This is 1/4. Base length is 2 minus root 3 all squared, and then the tan of 15. And this is my B up here. Okay, so we got it. We have everything we need, and hopefully there won't be any mistakes that are being made, and we'll calculate this now. So let's put this all together. So the area is a square minus 4a minus 4b. Okay, so here we go. So the square is, where's the square? It's right here. Sorry, right here. It's 2 root 3 minus 1 all squared. Okay, we got that. Okay, so then we have to multiply 4a. And then 4a is 4 times this 1/2 root 3 minus 1 all squared. And then we have to subtract the 4b, which is 4 times this 1/4 2 times 2 minus root 3 under the square root all squared, and then times the tan of 15. Got it? Okay. All right. And the tan of 15, for those of you who don't know, some of you can figure this out, is 2 minus root 3. You can use like trig identities to figure out, usually like the tan of 30, or sorry, the tan of 45 minus the tan of 30. You guys know those trig identities. So I'll let you guys do that. Okay, so then we just crunch out these numbers, and I'll let you guys do all that. But I just got to make sure that it's correct. This is the square, right, from up here. And 4 times a. So 4 times 1/2 times this guy. Okay, that's correct. And then 4 times b. So 4 times 1/4 base length squared times the tan of 15. And the tan of 15 is going to be 2 minus root 3. All right. Yeah. So when you crunch out all these numbers, you get 16 root 3 minus 23. Now they're saying that's equal to m root n minus, is it plus p or minus p? It's plus p. Okay. Plus p. So that means my m is 16, my n is 3, and my p is actually negative 23. So m plus n plus p
would be 16 plus 3 minus 23, and that looks to me like -4. So -4 is the answer to this challenging question, and that would mean the answer is B.